What you're seeing here is not just rubber being dipped into liquid. This is the exact moment a glove begins its life. These ceramic hands are heated before entering the latex. That heat is important. It controls how thick the glove becomes. As the mold enters the liquid latex, gravity and temperature work together. Before any glove is made, the molds must be perfectly clean. Any dust or residue would weaken the rubber and create holes. That's why these molds pass through acid and water baths.
The ceramic molds enter the preheating phase, where temperatures rapidly rise, preparing the material for the final casting.
But this next step is where chemistry takes control. The molds are coated with a coagulant, a chemical layer that forces liquid latex to instantly solidify when they meet. Without this layer, the latex would simply slide off instead of forming a glove. Now the molds return to the latex, this time for strength. This second dip determines how durable the glove will be. Every curve of the fingers, every contour of the palm is shaped naturally by liquid flow.
The wrist and cuff edges thicken naturally, with subtle ripples visible on the latex surface. The molds are now moving toward the next heating tunnel.
No cutting, no stitching, just controlled chemistry and gravity working together. Inside this heating tunnel, the latex undergoes vulcanization. Heat causes the rubber molecules to link together, transforming the soft coating into elastic material. This is what gives gloves their stretch, strength, and resistance to tearing. Too much heat, and the glove becomes brittle. Too little, and it stays weak. After curing, the gloves still contain chemical residues. To remove them, the gloves are washed repeatedly in water baths. This process, called leaching, is critical for safety. It reduces skin irritation and removes excess proteins that can cause allergies. The cleaner the glove, the safer it is for medical and industrial use.
Washing away soluble proteins and unwanted chemical residues.
Now the gloves are dried using controlled hot air. Moisture removal stabilizes the rubber and prepares it for removal. At this point, the glove has reached its final physical form. Flexible, durable, and ready to be tested. Removing the glove may look simple, but it's carefully engineered. The cuff is loosened first, allowing air to enter between the glove and the mold. This reduces friction and prevents tearing. As the glove peels away, it naturally rolls into its final shape, ready for use. Every glove must pass inspection. Some are inflated with air to reveal weak points. Others are submerged in water to detect invisible leaks. Even the smallest hole means rejection. This is why factory-made gloves are far more reliable than they appear. Approved gloves are automatically counted. And aligned. No human hands touch them during this stage. Automation ensures hygiene, consistency, and speed. Each box contains gloves that have passed dozens of controlled steps. From liquid latex to a finished product, every glove is the result of chemistry, heat, and precise timing. Something simple, created through an incredibly complex process.